Hello and welcome to the Replacement Therapy Lab for MCG4152, Design of Artificial Organs. So here's just a quick outline of what we're expected to go through in this experiment. We're going to have three separate containers, one representing the patient, one representing the replacement fluid, and one representing the waste fluid. Basically, we're going to put a salt packet into our patient, turn on the pump, which will draw water out of the replacement fluid beaker into the patient and then out of the patient into the waste, and we'll measure conductivity as a measurement of the solute levels in the patient. But first, in order to have some sort of reference to what our conductivity levels mean in terms of grams per ml, we have to create a concentration gradient of salt, in which we're going to start with a 32 grams per liter mixture and dilute that 7 times in order to get our standard, which will leave us with a dilution standard of 32 grams per liter, 16 grams, 8, 4, and so on. So the first thing we're going to do is, since we have 50 ml flasks, we're going to measure out our salt. That will give us 32 grams per liter. And we're going to start by just putting on our weigh boat and tairing that. Taking our salt packet, pouring that into a separate weigh boat and measuring out 1.6 grams of salt. So once we have our salt measured out, we're going to pour our 1.5 grams of salt from our packet into our falcon tube, and then add in 50 mLs of deionized water to get our 32 grams per ml concentration. So now we're going to measure out 50 mLs of deionized water. And we're going to add our 50 mLs of deionized water to the salt we have measured out, the 1.6 grams. And this gives us our first mixture for our conductivity standard. And now we shake and mix it up. And we can start the creation of the rest of the standard, which first involves adding 25 mLs, or half of the 50 mLs that we'd put in for our first vial, to the remaining falcon tubes. So from here we take our 32 grams per ml falcon tube that we just made, and we perform a serial dilution, taking out half of the fluid in the 32 grams per ml falcon tube, adding it to the next, and then repeating the process for the remaining falcon tubes. And this will give us a range of concentrations from 32 grams per ml down to 0.5 grams per ml, and then 0 just being our deionized water. So now that we have our standard mixed, the next step is to measure the conductivity levels of each of our standard concentrations. And the first thing we're going to do is just rinse off our conductivity meter. And we'll begin the measurements of our standard, starting from the lowest concentration, moving up to the highest concentration of 32 grams per ml. And going from the lowest concentration to the highest concentration will prevent us from transferring solutes from one falcon tube to the other as we measure the whole standard. So from here we leave the probe in our standard solution for enough time so that the measurement can equilibrate and we can get a final answer that doesn't shift too much on the screen. So after we get our measurement, we just replace the falcon tube and we can move on to the next solution. And again, in this case, as we're going measuring increasing concentrations as we go from left to right, we should see a higher measurement on the screen. Just to note, this screen shows a range from millisiemens to microsiemens. So in the initial measurement, it was 14 microsiemens, and now we're in the millisiemens range. So now that we have our standard samples all measured, we can now write our results down in a table. So here's a sample standard that I measured, and this allows us to relate the conductivity measurement to the concentration of our solution. So again, now that we have our standard all set, we can now begin the experiment by making our patient, replacement, and waste beakers. So again, I've taken 3 beakers here, and I've just labeled them replacement, patient, and waste. And now I've just added the required volumes to the replacement and the patient beakers. It's always okay if there's a little bit more liquid in the replacement beaker. So now with our beakers filled to the appropriate volumes, we can begin the setup of our peristaltic pump. In this case, we'll be using this pump, which we can run forward or backwards. In this case, we'll always be running it forwards. Begin the pump, you flip this switch, which again will put it forwards or in reverse, and you can move this dial to adjust the speed of the pump. So with our pump set to the appropriate speed, we can begin putting the tubes in each of the appropriate beakers. So there are 2 sets of pumps, or 2 sets of tubes set up around this pump. One set of tubes will bring water out of the replacement beaker and put it into the patient, and one will take it out of the patient and put it into the waste beaker. And again, this is just a short demonstration of how the peristaltic pump is running, and you can see the rollers slowly pressing in on the tubes, and this is just a side angle of it running. So the way the peristaltic pump is working here, we have rollers in the peristaltic pump that are compressing the tube as they rotate, and this is going to create a vacuum that actually draws the fluid through the tube. However, in the case of peristaltic pumps, the fluid is only touching the inside of the tubing. And so this removes the risk of either the pump contaminating the fluid or vice versa. Again, the tube here is completely closed when it's being squeezed by the roller in the outside track, and so this is what's granting the pump its positive displacement action and preventing backflow. And a consequence of this is that we don't need any check valves when the pump is not running. So now with our peristaltic pump all set up, we can now begin adding food coloring to the replacement fluid or the patient. In this case, we're going to add yellow food coloring to the patient and blue to the replacement fluid. And we'll also add a salt packet to the patient that will represent the solutes in the patient's fluid. So again, we're going to add the blue food coloring to the replacement and mix that up, as well as the yellow food coloring to the patient. And so once everything's added, we're going to stir each mixture very well. In the case of the patient, we want to be very sure that everything's mixed together very well because we put the salt packet in, so we want to make sure the salt is evenly distributed throughout the solution. And we're now going to make our initial measurement of the solution using our conductivity meter. And now that we made our standard, we can later compare this measurement to our standard to get an idea of the salt concentration in our patient. So the final step is to put our waste beaker on a scale, which will allow us to measure the pump speed. And this is going to be done by running the pump and measuring the change in weight over time, which will allow us to measure the weight change in volume over time. So again, we're going to tare our waste beaker so that it's at 0. And we can now move on to the next phase of the experiment, which in this case will be running the setup, replacing the patient's solute-filled fluid with clean replacement fluid, and depositing of the waste accordingly. So again, like I had mentioned, we're going to measure the speed at which the pump is running. And so again, once we hit start, water's being drawn out of the replacement fluid, which you can see the blue fluid going up in the tube, out of the patient, into the patient, and then fluid being taken out of the patient and into the waste beaker. And you can see the scale, numbers on the scale moving higher and higher, and this is the water moving into the beaker. And if we measure this over time, 1 gram is roughly 1 ml, so we can measure the mLs per minute, which gives us a speed of our pump. And so in this case, I'm just going to take 3 measurements, 1 at each minute, and this will give us a good average of the pump speed, or the speed at which the pump is running at. And so now, after 3 minutes, we're also going to take a measurement of the conductivity of our patient, and you'll notice it has gone down from the roughly 8 millisiemens that it was before to 6.2. And again, every time we take a conductivity measurement, we want to make sure the patient's solution is mixed very well, just to ensure that the salt hasn't settled. And we'll continue to do this throughout 20 minutes. So with all our measurements taken, just notice the change in our patient's coloring. It's gone from yellow to sort of a green color, and this is again because the replacement fluid has gone in, mixed with the patient, and the remaining fluid's been dumped to the waste. So we end up with a change in color. So here are just some sample readings again from my measurements of the pump of the patient, and we've completed the replacement therapy lab. So from here, just follow the remaining instructions. I hope this gives a good idea about how the lab was set up and what was going on throughout it. And thanks for listening, and I'll see you in the next one.